Can you see my screen?
Yes.
Okay. Hey, hello everyone. Thank you very much to hear our presentation. We are the team HKU TransGP. My name is Yinqiang Zhang, a PhD student at the University of Hong Kong. Another team member is Lu Liang, a postdoc belonging to both HKU and Center for Transformative Government Production. Our advisor is Professor Pan Jia. In the next 10 minutes, I will introduce the entire implementation that got the second place in the NSS challenge on behalf of our team. This includes the introduction of our framework, the implementation details in each submodule, and some results evaluation in this challenge. Okay, I'd say by winner team in this challenge, it is a spatial tempo registration problem, and at the left side we can see that this spatial tempo. This problem is that all the scans are initialized around the origin, and the color represents their different time stages. Our task is to align them in a common coordinate frame, as shown in the right side. So this one is the z-axis represents its time stages. To solve this, we follow the overall framework to separate the original problem in three stages. Well, we first need to obtain the transformation between each scan pairs by pairwise registration. This is a putative, and we will registration all scan pairs, and then we use the predict transformation and additional information to construct enhanced postgraph. This includes the initial postgraph from the dataset inputs and the information from the pairwise registration. Finally, all this information will be sent into the mature multi-way registration module for outlier rejection and transformation synchronization. Yeah. So let's begin. So in the pairwise registration, we actually use the learning-based method. We train a model following the baseline method overlap predator to predict per point features and per point overlap confidence of two scans by filtering with overlap confidence and feature matching. The correspondence points are selected and are fed as inputs into a global registration algorithm. Here we just use the TS++ method to achieve a global cross alignment and use the GSP method for refinement later. The overlay prediction can significantly reduce the search place during registration because we see that in the data set, the overlap ratio is low, and you can see the results for these two examples. We can find that although the overlap between the scan is relatively low, but we can still find the correct transformation between them. Note that two things should be emphasized in the pairwise registration part. Yeah. First, not only the transformation matrix between the scan pairs, we collect the in-layer number from the global registration algorithm as an indicator of the registration confidence. This indicator will be used in the following multi-way registration. Both data types, namely the transformation matrix and the in-layer numbers of in-layers, will be saved in a matrix tab and used in the following two submodules. Also, a pairwise registration of any two scans will be executed. This is time consuming, but this will be optimized in our future work, such as we will learn a global descriptor to directly compare the descriptor to find the overlap. Yeah. Second, then the transformation matrix. After we get the transformation matrix and the numbers of in-layers in the of any scan pairs, we will use them to construct the postgraph for multi-way registration. However, due to the outliers and the nonlinear optimization, a good initial state of the postgraph is essential. Therefore, we particularly design ways to initialize the nodes and edges in postgraph. This part include two branches. It's about the edge initialization and the node initialization. First, to initialize the possible connector edges between scan nodes, we generate the adjacent matrix from two information sources. First, the testing dataset gave us an initial postgraph. This can be a strong pair for scan overlap. like odometry in the SLAM settings. So we directly use this age as an initial. Also, we will use some high confidence age information from pairwise registration. For example, this is the in-layer number matrix from the pairwise registration. We can, for example, we set a threshold to the inlays. If the in-layer number between two scans is larger than this threshold, we will select it and generate an age between them. Yeah. So with these two adjacent metrics, we get the enhanced post graph. The word enhanced in other words means that the initial post graph are enhanced by the high confidence ages from the pairwise registration. Yeah. On the other hand, we also initialize the node from the initial post graph because that we can extract a minimal spanning tree from the initial post graph to get a tree-like structure, and the weighted are selected by the in-layer number. Then the initial node transformation can be recursively computed along the tree. And using this method, we can see the overall structure of the point cloud is correct, but with so many noise. So the problem will be addressed by the multi-way registration with the enhanced post graph and the noisy initial node transformation. Yeah. So next, after the post graph construction, we directly use the implement Open3D multi-way registration method implemented in Open3D and fine-tune to achieve a multi-way registration. Not that all the ages are set and uncertain, but the initial confidence is different. For example, the odometry-like ages from the initial graph will be set with high confidence, and the ages from the pairwise registration will not set as so high confidence. So after this transformation synchronization, the results is shown here. This is a demo data set from the validation side. We just use it to show the framework, the pipeline of our algorithm. Yeah. Although the entire implementation is simple and direct, it's very effective. In addition, after the deadline of the submission, we have more time to improve the results, and the current version of the results can be visualized as follows. This is the results as yesterday. Although the second place, but still a large improvement compared with the final version before the submission deadline. Yeah. Okay. Here we only show some cross results, not like the winner team. Here we give some visualization of the registration results. Here, the different color indicates the different time stages. We represented along the z-axis to make it more clearly to see it. The first row shows the side view, and the second row shows the bird side view. A bird view, yeah. Here we show for the four largest data set. All of them has hundreds of scans from about 700 to the largest about 1,400. And this is another two data set. Yeah, we don't show too much results, and that's all. And that's all for our team. And if you have any questions, please ask and feel free. Yeah, thank you.
Great, thank you very much for the presentation.
Yeah.
So I think for the sake of time, we'll move on to our next